What's up guys, Shawnthebro here, and we're back for another episode of the fighting game tutorial series. In this episode we are going to be going over more cleanup for our character class. So in the last few episodes of the series we have been going over cleaning up our code as we get closer to things like rollback netcode, advanced AI, and story mode. With a lot of the improvements we have converted tons of blueprint logic from the character to C++, we have cleaned up the branching paths, we have made things easier to edit and more dynamic. We've reduced complexity, we removed unnecessary assets and functions and variables, and overall just made the code much neater. And we're getting a lot closer to our finalized product before we get into these advanced mechanics, because we really don't want to be fighting ourselves when we are trying to implement these more difficult features. So this episode we're going to be continuing cleaning up our character blueprint. And as I mentioned, previous few episodes we were cleaning up many of the blueprint functions, converting them to code. We're going to keep doing that today, and specifically we're going to focus on our hitboxes. So we go back to the main menu and go to our practice mode. You'll see that we have our hurtboxes right here. So these hurtboxes are basically indicative of where we can take damage, where we can push each other, where we can throw each other, and the hitbox has to collide with the corresponding hurtbox. In the case of damage, to damage our opponent, we have to hit their green hurtbox that you see there with our red strike hitbox. You'll see damage is occurring when I'm hitting this. If I don't hit it, then no damage occurs. The proximity hitbox, which is that yellow hitbox, is what can trigger a character to auto block. So if they're backing up and meeting the conditions when the yellow hitbox hits them, they'll go into auto block. The blue hurtbox is the throw hitbox. I can only throw them if a throw hitbox collides with their blue hurtbox. And I can't really do it because they're blocking right now and I haven't set up that state. And so on and so forth. There are more rules for this. But these hurtboxes can change their properties based on if we're in a certain attack, if we're in a certain state, such as crouching or dashing or jumping. And since these hurtboxes can be changed, we were modifying the hurtboxes or resetting the hurtboxes based on the state we were in. And all this logic is currently in Blueprint, but there's no reason for this. We have everything we need in the code. So we can make this more efficient by converting it to code and give us more power and the ability to modify this from more places by converting it to C++. So that's what we're going to be going over for today's episode. If you want to get caught up in the entire series before covering this episode, you can learn how we've done things like our different projectile attacks, our charge attacks, our input buffer, our hitboxes, and a whole lot more. I'll link you to the entire fighting game tutorial series playlist right here in the top right corner. Alternatively, if you don't care about that and you only care about the character cleanup, having a clean character class and converting blueprints to code, you're still in the right place. You don't have to watch the entire series to follow this episode. I do recommend that you watch the other episodes on converting blueprints to code within our character class, because a lot of these are building on top of each other. You can get the proper ideas in your head about why things are better in some places versus others, or why I think they're better when we convert them to code and why they're more efficient. If you're interested, I'll link you to the first episode of cleaning up the character class right here in the top right corner. With that out of the way, we can go ahead and get started. Now, this is a code and blueprint tutorial series. Again, we're going to be converting logic from blueprint to code, so we're going to be working in both today. Let's start in the blueprint so we know what we're converting. So if we go to blueprints, character BPs, base character BP, we have two functions in here called modify hurtbox and reset hurtbox. I want to convert both of these to C++. So if we go into modify hurtbox, here is our behavior. So essentially we have the ability to enable or disable a specific hurtbox at a certain time. So if it's disabled, we just reset the scale to all zeros. We could also deactivate it or just disable collision. This also works. However we want to handle it is fine. If it is active, then we take in the index because we're determining what hurtbox we're actually modifying. We have an array of hurtboxes on our character. This is already a C++ variable. It's an array of static mesh components. Then once we grab the corresponding hurtbox, we're setting the scale to the values that come in here. We have width and height. We don't have depth in here, but since creating this function, we do have the 3D fighter. So we probably should have depth in here as well. So we can just make a whole scale variable here, or width, height, and depth. And we're just setting the scale based on this. And we have our default scale of 0.05, but again, if we have depth, we'll go in from here to here, or from the function parameters to the set world scale 3D. Then we were also getting the relative location of the hurtbox from the character and adding this offset to it in case we wanted to move the hurtboxes for some of our attacks or states. Once we add the relative location and that offset together, we set the new relative location of the hurtbox that we got from the simple hurtbox array at that index. And that's really all we need to do to modify the hurtboxes. Then we have the reset hurtbox, which is to just put everything back to the default spot that it was at. So all of our characters have default locations for our hurtboxes. In our base character BP, we haven't set it up because this is the parent to all of them. But if we go to something like mutant BP and go to the viewport, you'll see that this character has the hurtboxes set up by default. So we have this system in place called hurtbox defaults, which is a structure of all the hurtbox details for all of our hurtboxes at the initial state or their default value. Then we just reset everything back to that world scale and that relative location. This is another function that can easily be converted to code. That's what we're going to be converting today, so let's get right into it. First is modify hurtbox. So if we go to the code, and specifically go to fighter-template-character.h, we can scroll down to where we want this function to exist. And it doesn't really matter where, as long as you like the order that it's in. I don't think I have a lot for hurtboxes in terms of functions, if any. We have our structure in here for our details and hurtbox complexity, like 2D versus 3D. And then we have our arrays for our hurtboxes. So the best place for me to put it would be next to the hurtbox complexity, which was up here. Reset hurtbox complexity. And this is a blueprint implementable event, but we'll come under here and we'll say modify the properties of a hurtbox by the hurtbox index. And we can make it a U function that is blueprint callable, because we definitely may want to call it from a blueprint. For example, we could want to call it from our animation blueprint. So when we're in a certain animation, we modify the properties of the hurtbox. That is very, very common. And we're going to call this void modify hurtbox by index. And I'm giving it a slightly different name than the blueprint function name here, just so that there's no conflicts, but you could call it the same thing just as long as you remove your blueprint function before going back into the editor after making these changes. So simply making it modify hurtbox is fine, just be aware of that. But I'll actually call it modify hurtbox properties. I think that is perfectly fine. Now let's set up all of our parameters on here. So in here we made it is active, then index, then width, then height, then offset. We can follow the same setup if we want. We don't have to, but let's do it. Bool is active. Then next was our index, which is an integer, so int hurtbox index. Then we had our different scale values, our width and our height. Again, I think I'm just going to make this a full scale now so we can support both the 2D and 3D hurtboxes. So F vector hurtbox scale. Then we have our offset, which is an F vector for our location as well. F vector hurtbox offset. And you can keep these names the same if you want. You don't have to put hurtbox here or anything like that. I go back and forth a lot of time with what I want to name my variables. I do like to show my different thoughts in the series. Like if I start out naming them and I rename them, that's perfectly normal, perfectly okay. So we have our parameters here, and this will be good enough for now. We may want to add more later, depending on if we have other things we want to do with our hurtboxes. Let's go ahead and also make our other function now. Reset the properties of the hurtboxes to the default values. To their default values. We can make this U function blueprint callable as well, because again, there's a very good chance we're going to want to call this based on animation states or certain things that we do with our character in blueprint. We'll call this void reset hurtbox properties. Reset hurtbox does not have any parameters that it takes in, and neither of these functions return anything. So we're good to go at this point. Now we just have to fill these functions out. So I'll go above successful taunt to keep it in the same order in my fighter-template-character.cpp. So we can either just scroll down to this function manually, or we can type it in. And this is where we want to make our new function. So void a fighter template character, : modify hurtbox properties. And remember, our parameter list is bool is active, int index F vector scale, and F vector offset. Then for our other function, it is void a fighter template character : reset hurtbox properties. No parameters. Now we have to convert the logic. So if we go back to modify hurtbox, we check if it's active before doing anything else. If this hurtbox is inactive, again, we were setting the world scale 3D to be nothing, which is one of our options. To stay consistent, we can do that, but you don't have to do it that way. So if is active, else. In the else statement, that means it's not active. So this is where we would do the logic to set the world scale. But since we need to grab the hurtbox regardless of which path we go through, I'm going to go above the if statement here. Find the hurtbox based on the index. So we have our simple hurtbox array. So what we're going to do is if simple hurtbox array dot is valid index, and we're going to pass in index. This should be good enough, because if this index exists, it only contains hurtboxes, or really it contains static mesh components, but that is essentially the same thing in this case. And we want to put everything within this if statement, because if we don't have a hurtbox at that index, then there's no reason to do anything else in this function. If it's valid here, we can just get a reference to this if we want, or we can just use the value from the array. Every time doesn't matter, but this is a uStaticMesh component pointer. That's what this is an array of. We're going to call this hurtbox equals simple hurtbox array, and you can do it at the given index. Now this pointer should be valid because, again, this only contains static mesh components, and we know the index is valid. So at this point, we can just access it. So else, if it's not active, then hurtbox set world scale 3D, and we can pass it an f vector 0 vector. This will make a vector of all 0, so the x, y, and z will be 0. If it is active, however, we need to set the world scale to the width and the height that was passed in. In the case of our code, we just need to set it to the scale that is passed into the function. So hurtbox set world scale 3D, and we're going to pass in scale. Then we have to add the offset passed into the function to the relative location of the hurtbox. The relative location is the relative location in regard to the parent, so where it's at in relation to the root component of the base character BP, and then set the relative location based off of that. So hurtbox set relative location, and we're going to set it to hurtbox get relative location plus offset. So scale the hurtbox, offset the hurtbox, set the hurtbox's scale to 0 to hide it. And there we go. Modify hurtbox properties is finished. This is fully converted. At this point, you could actually get rid of this entire function. Now we do use it in a few places, so if you do go to remove this, then you have to replace the references. So what I'll do for now is just disconnect it. That way we can test it before removing it, but we're good here. Next, let's go into reset hurtbox. With reset hurtbox, we're just looping through all of the hurtboxes in simple hurtbox array and setting them back to their defaults. So let's start off by doing this. So reset hurtbox properties, we're going to go for int I equals 0. I is less than simple hurtbox array dot num, so the number of elements in that array, and then plus plus I to increment each iteration. Then we have to make sure that we have defaults for the hurtbox. So for every hurtbox that we have, we set the default values for it, but we still need to grab it. So we have this thing called hurtbox defaults, and it should have the same amount as the simple hurtbox array, because again, one is created and added for each hurtbox that we have. But just to be on the safe side here, you should add an if statement. If hurtbox defaults dot is valid index and index I. That way we know we have something at that index in the array, and then we can simply grab the hurtbox defaults at index I. And in this case, we're getting the index here and we're breaking it to get the scale and the offset, and we're just resetting this for each element in the simple hurtbox array. So we can do dot scale, and we can do hurtbox defaults index I dot offset, and we need to grab simple hurtbox array at index I, arrow sets world scale 3D, and we're going to be passing in that hurtbox defaults I dot scale. And we're going to do the same thing for the offset. So simple hurtbox array at index I sets relative location, and we're passing in those hurtbox defaults offset. And now this is reset hurtbox properties finished in code, which means again we could remove this, but I will just disconnect it for now so we can make sure we replace all references to it. So now let's go and relaunch the editor. So now the editor is back open, and what we can do is just replace all of our references with this version of the function. So we can go into any blueprint, like back into our base character blueprint, and go to Find Results and click the binoculars, or just go to the Find in All Blueprints section, however you want to do it. Then search for these functions. So modify hurtbox. You'll see it's only in the base character BP here, and it's used in the animation blueprint. So we want to go to every instance in the animation blueprint, so mutant anim BP, and just replace these with the character reference modify hurtbox properties. This is our C++ function. And you can pass in the same values that you were in the animation blueprint before. So it is active, we're modifying index 0, and the scale is going to be 0.7 on the Y, 1.0 on the Z, and the X wasn't here before, but since we are using it now, we need to make sure this is whatever value our default is for our characters. Now we should have this defined somewhere. I think right now we've just been hard setting this one. So if we look at our hurtboxes here, you see that the scales in here are all 1.0. Let's see what they are for something like our mutant BP. Viewport, and let's say our hurtbox high. It's all 0.05. If we're using the scale for all of our hurtboxes, then we want to use that value in here so we don't reset it to 0.0, which would then hide it. So be aware of that. For now, we can keep it like this, but just be careful not to leave this as 0. For the offset, just bring the values right over. So 25 and -25. Then once you have it copied directly, you can replace the old node with the new node. And we're just going to do that for all these modify hurtbox calls. So is active index 1, 0.05, 0.5, and 0.5. And the offsets are going to be 43 and -65. Is active is true, index is 2, scale is 0.05. The Y is going to be 0.9, and the Z is going to be 1.0. For the offsets, we're going to have 15 for the Y and -40 for the Z. Next one here is going to be is active is true, index is 3, the scale is 0.05, 0.75, and 1.05. For the offset, it's going to be 0, 25, and -25. For the last one in this section, we are going to have is active is false, index is 4, scale is 0.05, and I set the width to be 0 and 0 for the height. This means you could actually set it to 0 for the scale as well, and then the offset is going to be 0, 0, and 0. Since it's inactive, it's going to set these things by default, but I'm just mimicking what we had in here. So at this point, we can connect all of our functions and remove the old ones. Make sure you pass in your character reference here into your target like we were before. We still need to do that. All right, now let's go and find modify hurtbox anywhere else it is in this file. It's in a few other places. So next one is here. This one isn't actually hooked up, so if you want to use it and convert it, you can. It would be the same as the other techniques. So we drag off of character reference and call modify hurtbox properties. And we would set this to be active, index 0. For the scale, it would be 0.05, 2 for the width, and 0.3 for the height. For the offset, it would be 0, 0, negative 50. Then you would just plug it in here. And there you go. That's another one down. We can clean this up a little bit. And then we would go to our next one on the list, which is this one. This one is also not connected, but again, if you want to use it, just modify hurtbox properties. Is active to be true, index of 0, scale of 0.05, width of 1.0, and height of 0.7. Then for the offset, 0, 0, negative 20. And then just replace the old node with this. Then compile and save. If you find any remaining ones, there are 4 more. So we go down here where the remaining 4 are at. And these ones are being used. So we want to make sure we definitely replace these ones with modify hurtbox properties. We have all of these set to being inactive. So this makes it really easy to copy these over. Just make sure you set your right hitbox index or hurtbox index, which is 1, and then scales can be 0 and offsets can be 0. And do this for 2, 3, and 4 as well. Replace all of these nodes. And make sure you plug in your targets. And there we go. If you try searching for just modify hurtbox now, none should come up. It should just be our modify hurtbox properties. Once we have replaced all instances of this, we can go back to our base character blueprint, go to modify hurtbox, and remove everything inside of this function. Compile and save, you should have no errors, and that means you can remove modify hurtbox. Compile and save one more time, and you'll see that we are good to go. Now the other one is reset hurtbox. So we're going to do the same method. We'll do a find in all blueprints for reset hurtbox. And here you'll see that we have it in our base character BP. That's where we set it up. And then we call it twice in the animation blueprint. So we can go to these 2 locations. One is in resize to default hurtbox and notify. We can just simply remove this node and call reset hurtbox properties. Connect everything again with how we want it to look. And there should be one other one in here. So reset hurtbox. And do the same thing here. Just call reset hurtbox properties. And when we do this, that means we have eliminated all of reset hurtbox, the old function. And we can go back to the base character BP and delete everything in here. Compile and save, no errors, which means we can now delete reset hurtbox. So do that. No errors, and you are good to go. Now if you go and test this, you should be able to change your hurtbox size, which we can see in practice mode, so make sure this still works. So here we are with our hurtboxes, and our hurtboxes look good. Now if we crouch, they change, and if we uncrouch, they go back to normal, and that is what I expect to see, which means this worked. So there you go, guys. That's how you can resize your hurtboxes and modify your hurtboxes in C++ with no blueprint logic for them, which is cleaning this up, making it more efficient, and making it better to use for the future. If you enjoyed this episode on converting this blueprint logic to code, please subscribe and consider joining the Patreon, YouTube membership, and Discord subscriptions to help benefit the channel. Thank you so much to all who have. I'm really grateful for you, and I'm so happy you're enjoying the series. If you ran into any problems following this series or any of my episodes, feel free to join the Discord community. There's a link in the description, and I would be happy to help you out with any issues you ran into. Thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.